Hey, everybody, I'm Jeremy Miller. I am part of the core team of the Martin Project and the original technical founder of this project. Today, I want to show you our library that we've built up over the years, how we've taken PostgreSQL, the relational database you all know and love, and we've totally turned it into a document database with a very robust feature set, we think, and a full-fledged event store um, for what we call sorry, I'm not going to try that one. Um, so moving on, let's start talking a little bit about what Martin actually is. So where it started out, many years ago, I was at a shop. We were heavily invested in a NoSQL database called RavenDB, and it was not going very well for us. Mostly because we had used it very badly. So let's not say I'm disparaging RavenDB too much. So, but what we came up with was, hey, before our busy season, we need to be making this application run a whole lot better. What if I just read about this new JSON B feature in Postgres? It does all this magic stuff with JSON. What if we quickly write our own document database over the top of PostgreSQL? Right? That's how the crazy idea started. One day I was asked, what are we going to call this thing? You aren't going to call it some really lame, boring name like exactly the name I was using at the time. So I said, no. And as fast as I could, I Googled what are the natural predators of ravens? And that led us to this cute little guy you see on your screen here. So this is a martin. I think that's specifically a pine martin, and they like to steal raven eggs. So switching to Martin as a technical project, Martin is an open source .NET library. It is not a server itself. It is just a very fancy way to access PostgreSQL. Underneath it is the NPG SQL library that every .NET application uses to talk to Postgres. Now, the killer feature, if you're using Postgres, well, you're saying, well, of course it's ACID compliant. That's what Postgres always is. But in terms of a document database or a NoSQL solution, this was actually very revolutionary for us at the time, 7 or 8 years ago. This is a huge advantage of, yes, you get to have all your document database productivity magic, but we still get to be ACID compliant like a relational database. It's a huge win. As the project went on, what was originally a sideshow of, oh, hey, it's an event store as well, has actually turned into be the main reason for Martin to exist as a full-fledged event store, a very easy to get up and going event sourcing solution. I'll get into just a little bit. And then you can see we do have some documentation. We have a documentation website. Please feel free to take a look around and see what we're doing. So we're going around a little while. What I'm hoping to, the outcome that we're all hoping for as part of this conference is that some real Postgres experts see what we've done and they write to us and say, oh, you silly folks, here's a better way to do things. And if you feel like you needed to do that, the Discord link right there, that's the fastest way to get hold of all of us. All right. So talking to a whole room and a whole audience of Postgres fans, this is all old hat, this is old news, but I still want to kind of go back over what's great about it. Martin is possible because of the outstanding JSON support. And we're not talking, some of the other databases have added SQL JSON support, other limited JSON types, but Postgres goes way beyond it. I still talk all the time about why we are only on Postgres. We use so many features that they have. We've deprecated this a little bit, but at the time when we started, it was very advantageous that we could use the PLv8 extension to Postgres. We could run JavaScript to transform, tear apart, modify the JSON within the database. Again, if you're here, you probably know Postgres has a very vibrant community. It's moving very quickly. It does a whole lot of things. Hosting is awesome. Development-wise, this is something I really like. Is I'm primarily a software developer rather than any kind of DBA or true database professional. But the fact that Postgres is so Docker friendly for a local development experience, being able to say, especially with Martin, download, make a fresh clone of your Git repository, run Docker Compose, and Martin is going to get you up and running very quickly. It's going to set up schema for you. Just get up and run. It's kind of what I like to call clone and go coding, right? It's Postgres has been awesome for us for that reason. Now, getting into Martin as a document database and a little bit of try to show a little bit of what we're doing and some of the SQL behind it. So I'm going to shift back. I'm going to shift over to code finally. All right. So we're going to walk through a very limited getting started kind of demo, and then I'm going to dig into the SQL that's generated and show off a little bit of the Postgres capabilities we're manipulating in order to build a document database. So as usual, any kind of code, this is C#. I need to connect to a database. This is pretty well hard coded to the database that's set up in a Docker Compose file. I'm going to start in just a second. So I'm going to start up a new document store. I'm going to tell it what database we're connecting to. We are initially going to just quickly persist a little driver document. Now, this one's flat, this one's simple, but this could be complicated. It could have addresses, it could have complex objects nested within it. Doesn't matter. It's all going to be stored in one JSON blob. We can change it, we can mold it, we can evolve it, we can go as fast as we want without having to spend a tremendous amount of time on database migrations. That's the huge advantage of a document database. I'm back to here. So just so I can make sure that I show off more of the Postgres features. We want to be able to, at some point in our application here, we're building a small ride-sharing application. If you're from Lyft or Uber, you're probably laughing at how simple this model is. Let's just go with it for now. So we know that we're going to be frequently querying on license type for drivers. So I want to build an index for it. I'm not dropping down to SQL. I'm still dealing strictly in terms of my driver C# object. I'm going to say I want an index for the license type field. It's going to use a default B tree. I'll show that in just a minute. When we get to events in a little bit, we'll show this as well. Now, just a little bit of code. I'm a Chiefs fan, so we're going to save a driver named Patrick Mahomes. It has a commercial license type. I'm going to create that, and I'm going to very quickly store it. We're going to come back to this. I'm going to talk about how we use Postgres upsert capability. That's been a big win for us. And just showing you, there's a little bit of stuff. We're going to commit a transaction with just this one document. We're going to load it up. We're going to take a look at it. We're going to verify that we think it's really what it was. Then kind of a neat one here. Code right here. If you're not familiar with .NET or C# itself, so this is a feature in .NET called LINQ that is allowing us to craft database queries in terms of our C# objects. So as a developer, not saying that we shouldn't learn how to do SQL, but what I want to do is I just want to be able to work fast. I want to be able to work in terms of my objects, my problem domain, my business concepts. So I could say from a session, I want to query drivers where the license type is commercial and grab it asynchronously. Martin itself is translating this into PostgreSQL SQL. So you can see if we ran this query, this is the SQL that gets cranked out. So you can see right here, we are actually reaching inside of the JSON document itself, parameterized SQL, and looking for license type. Okay. We're not yet taking advantage of SQL/JSON. I'll talk about that. So let me also, real quickly, just show you some of the SQL that gets generated out of this. So behind the scenes, not that it's that hard, but Martin's going to create, the first time you use a driver, it's going to reach up and say, hey, I don't see the driver table. I need to go create storage for this. You can see a table. So we have a primary key, always called ID. The actual document database, it's just a JSON bead blob, right? That's usually advantageous That's what enables this kind of approach to be so productive for a software developer, because I can constantly be evolving excuse me, the structure of my domain model. I can add properties, I can take them away, I can excuse me, I can add child documents within the structure, and I don't have to be changing the database all the time. If I am able to quickly change my mind about the structure in development time, not necessarily in production time, of course. But this gives me a huge ability to evolve my system. It means I don't have to be frozen in analysis paralysis trying to figure out exactly how this should work. I can just go fast. Now, um, when you talk about when I explain this structure, this whole idea of Martin to a lot of people for the first time, they kind of say, "Oh, wow, you can't query within the JSON structure itself, right? You can only grab it by primary key." No, we can grab it any way we want. We can query within the JSON because otherwise this isn't usable. Moreover, we can create indexes. It's just Postgres, B-tree, this case a B-tree index. We can define an encode in terms of our language. Martin behind the scenes, it's going to create an index for us. It's even smart enough to help us check, is this index still in the database matching what we say is in configuration? It'll help us make migrations. Um, and honestly, for as much as I've loved Postgres from start to finish, maybe some of the tables and views, the metadata about functions and tables and column structure, maybe not my favorite part of Postgres to work with. But coming back to the code, I want to talk about this one. I want to make one point here, and we'll talk about something else that I think is cool about Postgres. So I created this document and I said store. I told Martin to store this. I didn't explicitly say insert. I could, so that it would force an insert statement. I didn't say update, such that it would fail if the document didn't already exist. Instead, I'm saying store. We're doing an upsert here. If it exists, replace the data. If it doesn't exist, no worries. Just insert it. Just actually the opposite of how it works, but just go with me here. So the upsert functionality is really advantageous for a developer. I don't have to think about it, whether it's new or old. I don't have to write branching code. Did this document already exist? Did it not? Who cares? Just store it and be fast about it, please. Right? So for a software developer, this is one of the first things we stumbled into when we were first creating Martin. So a lot of us at the time, I told you we'd been using RavenDB, that was a document database, but most of us had a SQL Server or an Oracle database background. And right off the bat, one of the things we loved, we started building Martin about the time that Postgres 0.9.5 came out with the newly efficient upsert mechanism. So behind the scenes, that operation I was just talking about, it builds an upsert statement in Postgres. So that very efficient upsert capability that Postgres has, that, to the best of my knowledge, not every other relational database has. This is something we love. It's a small thing, but there's just so many small little sparks of joy in Postgres that we've really appreciated as we've used it over time. All right. Go back to more pictures of Martins. Let's talk about some other pieces of functionality. All right. Okay. So we talked about how Martin supports being a document database. And that was my original, myself and the folks with me that were building this originally. We needed to replace this RavenDB thing as a document database. At the same time, some of us were interested in event sourcing as a development technique, and whatever. Let's also throw a little event sourcing kind of feature set off to the side. So if you're not familiar with it, event sourcing is effectively making the change log be your master record for the system, rather than keeping a master set of this is the current state of the system. The account is exactly this amount right now. Instead, you capture the change logs, you model the transitions in state, and that's what you store. In reality, in a tool like Martin and many other event stores, what happens is you effectively store bits of JSON for things like if it's accounting system, account changed, or in a ride sharing system. I'm going to demo a little bit. Maybe say that um, a a ride has been ride requested event. A ride started, a ride finished, driver tipped. Hopefully, um, hopefully we all remember to do that, right? So you'll see little blobs of JSON. When we talk about some of the advantages, okay, so some of the advantages to event sourcing, why I would do that as a developer. Um, One of the great things about it is it enables you to make your code look a whole lot like the actual business language. When you're talking about these events, you can use almost exactly the same terminology your business domain experts use. So it sometimes, a lot of times, it makes it when you're building your requirements for a system. It helps you to create common language and understanding between you and your business partners because your code actually pretty closely reflects how they think about it themselves. So I work in healthcare, and we have some very strict HIPAA requirements about how things are audited. You know, what data was accessed, this data was changed. I've also worked in banking, where it's very crucial to keep a record of when did an account get debited, when was a payment made. So event sourcing is perfect for that. You can do that with Timescale. You can do it with other approaches, but the event sourcing is perfect. One of the great values of this, it's something called temporal querying or time travel. Um, what did the world look like at 1 o'clock yesterday? So we can take the events that we have and we can rewind to um, show me all the events from the start of yesterday to 1 o'clock yesterday and go compile that into a full stateful view. So it always gives us a reversible way to say, what did the world look like at a certain time? How did it change over time? Just skip some of the rest of it. Some of the other values. It's a great complement to a CQRS architectural style, and just talk about that a little bit. If you bumped into, if you're only casually familiar with CQRS, or if you go search this out for the first time, people will talk about having separate database structures for the write side, WRITE side of the database, where here this means with event sourcing, we're just pumping data in as JSON. And then talk about the read side, where from that event data, you may write out to a more readable document of here's the current state. In its scariest description, people will talk about it being two databases, which would make people be pretty upset. Why do I have to use two different databases for the same application and somehow migrate state changes between one and the other? Martin makes a lot of this go away by letting you capture the events to Postgres with a lot of capability to transform those events into documents, a document view of, let's say, if we're talking about building an Uber app, what's the current state of a driver today? He's constantly logging, I'm ready, I'm busy, I accepted a ride, I finished the ride, but we can compile that into the state of where's the driver now. That little bit of stateful document, that can also be stored in Postgres through Martin. And places where it's still absolutely appropriate or useful to write a flat table. If I want to write metrics on these events later, Martin will also happily let you project to a good old-fashioned flat table, and you can sum it. You can do all kinds of statistical analysis, all that powerful stuff we've always done with relational databases. So all that to say, using Martin with Postgres, that gives you an idea, a way of having almost every major pattern for doing persistence in an application with one database engine. And that's awfully nice. All right. To make that a little more concrete, I want to shift over to the code for just a few more minutes. Okay. So with event sourcing, slightly different use case. So trying to, again, let's say we're going to build a startup. We're going to try to compete with Uber for some crazy reason. Let me take that away. We don't care about that anymore. Folks, sorry, there's something I need to add here just so this makes the slightest bit of sense. Almost there, folks. All right. So now, say we're going to create a set of events for a single driver on a single day. So I'm starting my day. I log into the system as a driver, and I say, I'm ready. I'm ready to go. So in the system, it's going to record probably a shift started event and maybe something like a driver located. Hey, the driver is in this exact position. Through Martin, I'm going to start this brand new stream with this new made up shift ID. It's going to be a sequential GUID. And I'm going to save it. So at the time this happens, Martin is writing a couple of these little Vin objects. They're being serialized to JSON, being stuffed in a new table. I'm going to show that in just a second. Then I come back later as the driver finishes whatever he's doing. He can finally say, hey, I'm actually ready. So that gets appended as well and saved, appended to the same stream, which is just a logical segregation. It's one table. And we'll keep going. We'll do write accepted. And later, if I want to, if you wanted to, you could fetch the raw events. I'm going to show you what they look like in just a second. And then we talked about a little bit about having a read side view. So that is going to be called driver shift. So if I want to just see what's the state of a driver right now, I have a mechanism I'm going to use in Martin. So I'm going to say my driver shift. So this is just a model of what the driver is right now. What's the shift ID? This stuff, this is for concurrency. Let's ignore that right now. But based on the events coming in, I can start to record and modify this driver shift. I can say shift started. I know when the date is. I can start to see who the driver was, some other information. More events come in, driver ready. I'll mark the status. Status here is ready. Location switches to wherever they happen to be. You just see, I'm just going to scroll down to show a few more events. Okay. When we second. So when these events are captured, so this is the output of that test I just showed. So this is the events that are stored with a little bit of their metadata. So this part, this little bit of JSON right here, really that's stored in the body of a table with separate columns for a little bit of metadata. So we have to track what kind of .NET application this is, or what kind of .NET type this is. There's a little more information in here. We're connecting it to the stream ID. This is the driver shift. So a driver on April 3rd, this is when he checked in till the time he closed up for the day on like an 8-hour period. So these events are all related to that one driver on that one day. And we can track what version within the stream, overall, some other data, timestamps. We can support multi-tenancy, not using it in this application. But we got some open telemetry kind of tracking here as well. It's a little more clear. In the table itself, 2 big tables. But really, most everything is popping into one events table for right now. So no matter how many streams for the entire lifetime of the application, bang. So I'm going to come back to this at the end of the slide deck, and maybe talk about some advanced Postgres features we want to try to adopt to make this scale a little bit better. Coming back, show you one last thing. So this little bit of code right here. So I have just told Martin, I really want to create a running snapshot of the current driver's state. So every time an event is changed, we're able to update this view of the current driver shift. So where are they? Where are they? And what's their current status? Are they ready? Are they assigned somewhere? Are they unavailable? Is they're on a break somewhere? So there's going to be a lot of times when during the system, as the system is making decisions, I don't want to go fetch all of the events and figure out what they all mean. I just want to say, what's the current state? Or better yet, I want to say, what was the state of this user at this driver at 2 p.m. It's now 4, but where was he at 2? Event storing, event sourcing gives us capability to do all of that. All right, let me come back to the slides again. And so I happen to like this demo. Talking a little bit now about creating a really fast web service. I think that's a Japanese Martin, specifically running across the snow there. So one of the other great advantages of event sourcing, when we're building a web service and an application, and we're using that typical worldview of I have one database with the current state, but I will need to expose a web service to give some piece of information to an external service. Maybe it's even just our UI. What typically has to happen is I have to go load the data from the database. Maybe if it's in multiple tables, especially if it's a relational database. So it's all going to be joined up to get what I want. If I'm using an object relational mapper, the ORM is going to do a lot of crazy things, twist and turn, to build your domain model objects, set a lot of properties, read stuff from the database, transform it into your C# objects or whatever your domain model objects are. And then from there, even on top of that, once you have that data, you're taking your domain model objects, your internal representation of a driver, the current shift, all this other information. You don't want to necessarily put that over the wire in most cases. You don't want to have to couple your UI or the client to the exact shape of your internal model. So there's usually a whole nother step of transforming your internal representation to the representation that's going to go over the HTTP stream. Then on top of that, we're not done. I know I'm probably getting tired of me to explain this, but the system's not done. We have to take that final view model DTO type representation and serialize that to a JSON string, and then finally take that string and write it down the HTTP response. So there's a lot of steps that are happening in there. There's a whole lot of work and junk that's got to happen just to stream some JSON down to a browser. Instead, let's flip back over to the code, and I'll show you a Martin specific way to do this with more of an event source way. Boom, boom, boom. Sorry for messing that up, folks. So behind the scenes, I accidentally triggered like some kind of weird voice commands on my system. Love it when that happens in a talk. All right, so I've talked about a little bit about the idea of projections, maybe not enough. So in event sourcing, we have the raw events, and from those raw events, you may create projected views, which take those events, collate them into a representation of the current state. So in our case, in this ride sharing application, one thing we may do is we want to create a representation of where are all the drivers in a certain postal code at this time. If I want to look, my node zip code is 78750. I want to see what are all the drivers that are currently active in 78750 right this very second. So what we may do is say Martin is constantly keeping up to date a view of all these events that are coming in, driver ready, drivers logging out, shift started, and it is constantly incrementally changing this little summarized data. Okay? Here's just try to make this. Oh, don't look at that code. That's ugly. Just seeing a little bit of the sauce of how this is being updated. Just a ride ends. Oh, let's correct the code. So a ride ends. We'll say there's one less active ride, and when that ride ends, then we just kind of update. So the total mileage for all the drivers in that one zip code today, so we can say it increased by this much. Okay, from a web service now. So this data, let me just kind of connect the dots a little bit. So this piece of data here, this is at all times being constantly updated as events come in, but Martin is writing it as a document itself. So somewhere in Martin's structure, it is being written as a JSON data exactly the way that we want it when the UI needs it. So it's happening in the background process. There is a little bit of eventual consistency, but it's building the exact shape of the data from the raw events that are our internal representation to a view model of exactly what a client would need when they request it. It's already pre-built. There's no more mapping, nothing else. So you remember that long drawn out story of we're building a web service, we load the data from an ORM, it's running queries, it's transforming data here, transforming it again, serializing JSON, so on and so forth. In this Martin approach, I'm trying to show right here, let's make it a little bit nicer. This is an add-on to Martin. Giving a query session, which is just a Martin attachment to the database. I want to say I want to write the postal code summary for this particular identifier. So given the postal code and a certain date, I want to see what was the total for that day. How many rides? What was the total mileage? See what it is. So in one go, what's happening in this bit of functionality right here? This is loading the data from the database. In this case, it's reading the data by its primary key, which is that string identifier. And it's going to stream the JSON, pre-built JSON that's already stored in the database exactly the way we want it. It's going to stream it right down to the HTTP response. No JSON serialization, no transformations, no object creations, no blowing up the garbage collector, nothing, just byte by byte. There's a little bit of cleanup of some extraneous junk that Postgres puts in. But byte by byte, stream it right down. This is the absolute fastest possible way you could write a web service to get the data that your client needs. So this has always been something we've been excited about. This is something that's special to Martin. Again, it's just another way we've been able to take Postgres and use it in totally different ways to solve our actual business problems. All right, let me go back to the slide deck for just a little bit longer. So just thinking about, this is where we are right now, just talking about the future, and really, so I'm a glass half empty person with a code base. I have a tendency to just focus on what I know the lackings and the failings are most of the time. And a lot of our focus in the current year is going to be on creating massive scalability. How can we go to humongous data sets? So one of the things we have an issue with is that event source table. We say there's one event table that's being constantly appended to for the lifetime of the application. Right? That's obviously not going to scale forever. So we're going to looking at adopting some Postgres table sharding capabilities, and we will absolutely be looking at Citus, our sponsor here. That's an open source add-on to PostgreSQL that does table sharding, among other things. Um, looking at a way to kind of take these massive tables and quietly turn them into much smaller tables behind the scene. Um, look at that a lot. And one of the features I'm very excited about, um, newer versions of Postgres already supports the SQL slash JSON standard. It is, in my opinion, it's an easier way to author queries against the JSON bodies than the original Postgres operators. Um, so today, some of the more complex child collection query things we do, I do some. I'm going to take the blame for this. I wrote some very unclean SQL using window functions and CTEs and advanced Postgres features. Could probably be a whole lot easier with this SQL JSON and JSON path support. So that's something we're very excited about, and that's and as always, it's been continuously very hard for us to keep up with Postgres because the project, the community, it just moves so fast. There's always so much new stuff for us. Um, so we're excited about Martin. We're excited about the future, and thank you so much for coming to this talk.